Hello, my friends. Time to do some geometry. Today we're going to talk about the rhombus and the square. Before we get started with the new information, what I want you to do is pause the video and answer these 4 questions. So list all the properties for a parallelogram. Try to remember from our last couple of lessons all the properties that a parallelogram has. Then, number 2, list the 2 properties that separate a rectangle from a parallelogram. Number 3, list anything that you can remember about a square. And number 4, what do you know or remember about a rhombus? And can you draw a picture of a rhombus and list any of its properties? Give it a try and see how accurate you are with this stuff, and then we're going to go through and see how well you did. Pause the video, please. Answer these questions on a sheet of paper somewhere, just a scrap piece of paper. And then by the end of the lesson, we're going to see how well you did. Okay, so hopefully you have all your work done off to the side with all your different properties. Your 5 basic properties for your parallelogram that you're supposed to remember: opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Those are the 5 properties of every parallelogram. And remember that a rectangle is a parallelogram, so the rectangle has all of those properties as well as the rectangle has all right angles and a rectangle has congruent diagonals. Those are the 2 properties that separate the rectangle from the parallelogram. Now we're going to get into a rhombus. Now, rhombus is also a parallelogram. It is a parallelogram with some extra special properties. Just like the rectangle is a parallelogram with 2 additional properties, the rhombus is a parallelogram with 3 additional properties, but those 3 properties are different and separate from the rectangle properties. So the rectangle is a parallelogram with right angles and congruent diagonals. Those properties come as a package. If you have all right angles, as a result of that, you will have equal diagonals, and vice versa. If you have equal diagonals, then you have all right angles. Okay? So with a parallelogram turning into a rhombus, the one main property that most people remember about a rhombus, which you guys may call a diamond if you watched Mickey Mouse Clubhouse as a kid, but the one property that most students remember about a rhombus is it has all sides congruent. As soon as you take a parallelogram and force all 4 sides to be congruent, some other properties fall into place as well. Those properties are diagonals become perpendicular and the diagonals bisect the angles. So all of those properties come together in a parallelogram. So if you have a parallelogram whose diagonals are perpendicular, then as a result, it also must have congruent sides and diagonals that bisect the angles. Now, as far as the diagonals bisecting the angles is concerned, what I'm talking about is when the diagonals hit the corners of the rhombus, it bisects them into 2 equal parts. Since the opposite angles are congruent because it's a parallelogram, what happens is we have some alternate interior angles, which makes sense that they are congruent. And same thing is true for the other pairs of angles. Now, consecutive angles are still supplementary. Okay? So in rhombus A, B, C, D, angle DAB, the whole angle in the corner, is supplementary to angle ABC, that whole angle. One of the properties here was that the diagonals are perpendicular. So what happens here is when the diagonals intersect, we end up with 4 right angles. Since it's a parallelogram, we know the diagonals bisect each other. And since it's a rhombus, we know all 4 sides are congruent. So what happens in a rhombus, the diagonals create 4 equal right angles inside the shape, within itself. Pretty neat. Now, when you're trying to prove a shape is a rhombus, we have to prove it's a parallelogram first. So we pick one of these parallelogram properties, prove that's true, because they all come in a bundle. You prove one of them, then they are all true. Then we have to prove one of the other additional 3 properties. We have a formula to prove consecutive sides are congruent because we can use the distance formula to find side lengths. we have a formula to show that the diagonals are perpendicular because we can use the slopes and show that they are opposite reciprocals. However, we do not have any formulas to show the diagonals will bisect the angles. We don't have any formulas to find angle measures. So this third one will not be used as often. If we're dealing, it won't be used at all if we're dealing with coordinate proofs, but it won't be used very often in doing any kind of proofs until we get to ones that are not on a coordinate graph, just because there's no formula for that. Okay, so those are our rhombus properties. Let's put them into action. Given rhombus RSTV, find the measure of angle SVT if the measure of angle STV is 110. So pause the video, see what you can do, and then come back and we'll see how you did. All right, so one of the properties that we just talked about is that the diagonals are perpendicular. So that means that angle TWV, TWS, SWR, and RWV, those are all right angles. Those are all 90 degrees. Also, diagonals of the rhombus bisect the angles. So if the measure of angle STV is 110 degrees, then half of that will be 55. So then by the triangle angle sum theorem, we can find the measure of angle SVT. So let's do another one. We have a rhombus drawn over here, rhombus DLMP. DM is 24. Angle LDO is 43. And DL is 13. Well, if DL is 13, then we know all sides are 13 because in a rhombus, all sides are congruent. And if you know that DM is 24, then hopefully you remember, because this is a parallelogram, diagonals will bisect each other. So that automatically means that DO is 12 and OM is also 12. So with diagonals being perpendicular, I know that one of the diagonals is a full length of 24. That means each half is 12. You can do Pythagorean theorem. Use the 12 as the A, looking for the B, 13 as the C. Do Pythagorean theorem, and you can find OL. Then you can find PL. As far as our angle measures are concerned, triangle angle sum theorem. If angle DOL is 90, because perpendicular lines make 90-degree angles, and in a rhombus, the diagonals are perpendicular. With angle DLO 43, and that's 90, that means we can get our other angle, angle DLO, by triangle angle sum theorem. So we do 180 minus 90 minus 43, leaves us with 47 degrees. So now, pause if you need to, do Pythagorean theorem to find the length of OL, and then we can double it to get the full length of PL. So a squared plus b squared equals c squared. We end up with OL being 5, then we double that, so PL is 10. And then because opposite angles of a rhombus, parallelogram actually, opposite angles of the parallelogram are congruent, which means it's also true in a rhombus, we can find the measure of angle DML. Diagonals bisect each other, so I know that angle DPM is 43 degrees, and DML would be an alternate interior angle with that 43, so it's also 43. Or you can use triangle angle sum theorem. Diagonals bisect each other, knowing this one up here, OLM is 47. Lots of different ways we could find that measure, but it should still be the same result, 43 degrees. So rhombus has a lot of cool stuff in it. Let's check this out. How do we do a rhombus proof on a coordinate graph? Well, the first thing you're going to do is plot the points 0, 0, 4, 3, 7, -1, 3, -4, and label those points. So please pause the video, graph the four-sided shape, then come back and we'll do the proof. All right, so hopefully you have your shape drawn. We are going to prove this is a rhombus. Now, in order to prove it is a rhombus, we must first prove that it is a parallelogram. And I told you that the best way to prove a shape is a parallelogram is find the slope of all four sides. So, pause the video, please. Find the slope of all four sides. Pause the video. Find the slope of all four sides. You can count boxes. Once you have the slope of all four sides, what we're going to see is both pairs of opposite sides are parallel, so that makes it a parallelogram. Now, in order to prove this is a parallelogram, I need to prove it is a parallelogram with option 1, perpendicular diagonals, or option 2, consecutive congruent sides. So you don't need to show all four sides are equal. You just need a pair of consecutive sides. That means two sides next to each other. We already know, because it's a parallelogram, that both pairs of opposite sides are congruent. So if I also prove that consecutive sides are congruent, that means all sides are congruent. So you just need to pick two sides next to each other if you're choosing to do distance. I like to do slope. So I'm going to calculate the slope of both diagonals. When I find the slope of both diagonals, what I'm hoping for is that they are opposite reciprocal slopes. And when I see that they are opposite reciprocal slopes, then I can say PQRS is a rhombus because it is a parallelogram with perpendicular diagonals. That's just what we needed to do. That is what we did. So that's how you prove something's a rhombus. Now, let's take a look at the square. So a square is the combination of all the parallelograms into one. So it is a parallelogram, a rectangle, and a rhombus all in one shape. So to prove something is a square, this is the one that's going to take the most amount of work, but still, ultimately speaking, it's not that bad. What we're going to do is prove that it's a parallelogram first, because all of our parallelograms carry on the same 5 initial properties. Once it's a parallelogram, we also prove it's a rectangle. And if you remember correctly, I told you that to prove it's a parallelogram, find the slope of all four sides. With those slopes, we'll automatically see if we have right angles or not. We all know that a square has 4 right angles. So if in our efforts to prove it's a parallelogram by slopes, if we don't see opposite reciprocal slopes, then we know it's not a rectangle or a square right off the bat. Once we know that it is a parallelogram with perpendicular sides, so 4 right angles, then I can prove one of the rhombus properties. So ultimately what I have to do is prove that it is a parallelogram, a rectangle, and a rhombus all at once. So that's 3 sets of information, 3 statements. One statement saying why it's a parallelogram, one statement saying why it's either rectangle or rhombus, depending on what you do first, and then the last statement why it's a square. So we can show that a square is a rhombus with 4 right angles. We can show it's a rhombus with congruent diagonals, or we can show it's a rectangle first with 4 congruent sides, and technically we could also show it's a rectangle with perpendicular diagonals, or a rectangle with diagonals that bisect the angles. We don't have coordinate formulas to show diagonals will bisect the angles, so we'll use one of the other properties. It's up to you whether you want to do the explanation why it's a rectangle first, then a rhombus, or if you want to explain why it's a rhombus first, then a rectangle. That order doesn't matter, because ultimately it's the same shape, same result. So let's take a look at some of the properties of a rectangle, of a square. So the square is a combination of all the properties mixed together. So if I tell you that MA is 8, then what is AT? All right. If I ask you to find the measure of angle HST, because a square is also a rhombus, diagonals are perpendicular, so that's 90 degrees. What's the measure of angle MAT? Well, because a square is also a rectangle, all the angles of the square, MAT, are 90 degrees. If HS is 4 radical 2, So that would mean this half of the diagonal is 4 radical 2. What is the length of HA? Well, diagonals bisect each other, so the other half is also 4 radical 2. 4 radical 2 plus 4 radical 2 is 8 radical 2. And since the diagonals are congruent, because it takes that property from the rectangle, the other diagonal, MT, is also 8 radical 2. So then what is the measure of angle HMT? Well, we know because it's a square, all the corners are 90 degrees. And we know because it's a rhombus, the diagonals bisect the angles. So what happens in every square is the diagonals create 45-degree angles in every corner. So measure of angle HMT is 45 degrees. All right, so let's go back to the proof we did, proving that PQRS is a rhombus. We already took care of the fact that it is a rhombus. Let's prove that it's a square. With the work that we already did, we had both pairs of opposite sides parallel, so that makes it a parallelogram. A parallelogram with perpendicular diagonals is a rhombus, so we know it's a rhombus. So what else do we need? Well, we have two options left of what to do. Either show that the diagonals are congruent, just like the rectangle, or show that our rhombus has perpendicular sides, making all the angles 90 degrees, just like a rectangle. So we have to prove one of the rectangle properties. With the work we've already done, we already know it has right angles because our slope calculations show opposite reciprocal slopes. So the sides are perpendicular, which means we have a rhombus with right angles, which makes it a square. We already have the work we need, so we don't need to do any more. That's why I suggested use the slopes to prove something is a rhombus or a parallelogram. Because that work, if you need it, will also help show whether it is or is not a rectangle and square. And then you have to do just one other calculation. Once you know it's a rectangle, you just need one other calculation, slopes of the diagonals, or consecutive sides congruent, in order to show it's a square. So it's not really any much more work than the rhombus, depending on how you approach it. Just one extra statement explaining why the rhombus turned into a square. So now you're going to go off, practice on your own. I will see you soon, and let's see how you did from back at the beginning. The properties that you were asked to write down, what properties do you remember about a square? You probably got all sides are equal, all right angles, some subtle things like that. But really, you need all these properties would be all the properties of a square. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 unique properties that you could have written down for the properties of a square. It's the combination of parallelogram, rectangle, and rhombus all at once. So there was a lot of things there. And then what do you know about a rhombus? Well, did you know all these things about a rhombus? Hopefully you do now, because that's what you gotta have memorized. You gotta know all this stuff. So it's the 5 properties from the parallelogram. You could have listed any one or all of those, plus the extra 3 where all sides are equal, diagonals are perpendicular, and diagonals bisect each other, or bisect the angles. So that's our rhombus and square. Hope you're doing a good thing by doing your work, doing your practice, staying safe, staying healthy. See you guys soon. Take care.